Hi to you watching this video. So for this video, we are now on module number 2. We are still going to discuss about stresses, but this time we are going to be specific. It is normal and shear stresses on a plane. So it is good for you to have a review of what are the internal impacts of these external loadings to a certain element. Um, what is the value of the shear stress on principal planes, and what is the maximum shear stress. So you were able to meet this meet stresses, principal, maximum and minimum stress, major and minor stresses in your statics of rigid bodies on the latter part. So but if you were not able to discuss that on your strength, you were also able to discuss this. Okay, but this time we are going to apply it on soil profile. Okay, so for unit number 1 for this video, we are going to focus on the stress equations. So before we proceed with 2-dimension, let us first try to understand the 3-dimension. So for example, we have here a soil particle, or in a 3-dimension. We know that in a 3-dimension we have three axes. So we have the y-axis, the x-axis, and the z-axis. Okay, but for yeah, so if we are to analyze that, if we are to analyze a three-dimensional soil or particle, we can say that we have a normal stress along the x-axis, normal stress along the y-axis, normal stress along the z-axis. So we also have shear along the xy, xz, and yz axis. Okay, but for two-dimensional, we are going to understand it, or we are going to analyze it in a two-dimensional manner, because stress would affect vertical and horizontal, or vertical, horizontal, or in the axis of the y and the x axis. uh, Negligible yung sa z axis, almost equivalent to 0. That's why sigma z, tau xz, tau yz will simply cancel out. So here we will be left with the normal stresses, tau x, normal stress along the x-axis, tau y, or sigma rather, sigma x and sigma y, normal stress along the y-axis. Now for the shear stresses, it will be present on all sides, which is the stress along the x and the y-axis. So here is the soil element with stresses acting on it. So we have here the normal stress along the x-axis. This is the stress along the x-axis, normal. This is the normal stress along the y-axis, and we have here the shear stress along the xy axis. So shear stress along the xy axis. So these are the three components of the axis in a two-dimensional plane. Now, if we are to consider the plane EF shown, so this is the plane EF here, we redraw that, and it would look like this. So we have the normal stress along the y-axis, normal stress along the x-axis. We have the shear stress xy, and with respect to the plane EF, we have here the normal force. We also have here the tangential force. Okay, and of course, we will have an angle of inclination with respect to the x-axis. Okay, yan. Now, for the normal stress, it is perpendicular acting along plane EF. So, this is our plane EF. It is perpendicular. The normal force is perpendicular, or the normal stress is perpendicular with respect to plane EF. Okay? So, using the given, we can solve for line EB. Line EB, using cosine function, can be solved. So cosine theta is equivalent to FB, is equivalent to is equivalent to EB over, cosine function is equivalent to EB over hypotenuse. So cross multiplying, EB now is equivalent to line EF cosine theta. Likewise with FB, we use the sine function. So sine theta is equivalent to FB over EB, or EF rather. So cross multiply, FB therefore is equivalent to E sine theta. The next procedure is we consider the components of forces along N. Take note, we have equation 2.1 and we also have here equation 2.2. Now, considering the components of forces along N. So, the forces along N. So, we have here theta. We can solve the theta x with respect to the we can solve the theta with respect to the normal force using sine and cosine function, or our SOHCAHTOA. So we have here sigma n. So we have here sigma n, or normal force, times EF is equivalent to sigma x. So sine theta here, sine theta is equivalent to this side divided by sigma x. Okay, so cross multiply, magiging sigma x times FB, because it is on this side, FB sine theta. Okay, plus shear y. So since, para hindi kayo malito, although you can refer to the diagram naman, so since theta, sigma x is sine, and then therefore, tau xy here would become cosine. So tau cosine theta times FB. Okay, now we are going on this side naman na. So sigma y times cosine theta times cosine times cosine theta is equivalent to sigma over sigma y. Okay, so magko-cross multiply yon, we will be having sigma y times cosine theta times EB, because we are on this side. And we have here tau xy times sine theta. So sine theta times EB. Okay? Yan. So simplifying this, sigma n times EF times EF sine theta times sine theta plus tau xy times EF sine theta cosine theta. Now, saan nanggaling yan? We substitute here the value of EB. So EB here from our equation 2.1 and FB here on equation 2.2. So substituting the value of EB and FB. So we have here EB and FB. FB here, FB here, we substitute. So theta x, FB, so sigma x rather. Sigma x times FB, which is EF sine theta. So we have here EF sine theta times sine theta plus tau xy times FB. FB is EF sine theta, and we have there EF sine theta times cosine theta. So that is the second term. Now for the third term, we have here sigma y. So sigma y times EB. EB is EF cosine theta. So that is EF cosine theta times cosine theta plus tau xy for the fourth term. Tau xy times EB. What is EB? EB is EF cosine theta, and we have there EF cosine theta. Okay, so simplifying, we will be having sigma n is equivalent to sigma x sine theta squared plus sigma y cosine theta squared plus 2 tau xy sine theta cosine theta. Now dito napapasok yung ating trigonometric identities. So from our trigonometric identities, sine theta squared is also equivalent to 1 minus cosine 2 theta divided by 2. Likewise with cosine theta squared, that is also equivalent to 1 plus cosine 2 theta over 2. And sine 2 theta is equivalent to 2 sine theta cosine theta. So using our substituting and using our trigonometric identities, sine sine theta squared, papalitan natin tong sine theta squared with 1 over cosine 2 theta. Yung cosine theta squared, papalitan natin ng 1 plus cosine over 2 theta. And itong 2 tau xy, sine theta, cosine theta. Take note this here, we only have, so we have 2 sine 2 theta, we have 2 sine cosine theta. Then we can cancel that out and we are left with sine 2 theta. So substituting and simplifying, sigma n, or the normal stress is normal stress on a plane is equivalent to sigma n is equivalent to sigma y plus sigma x over 2 plus sigma y minus sigma x over 2 cosine 2 theta plus tau xy sine 2 theta. And this is our sigma n. So ganun din yung gagawin natin. This time naman for shear stress. So for shear stress, ganun din, we are going to use SOHCAHTOA. We're going to use SOHCAHTOA to equate and to get the relationship between the sigma n, the sigma xy, and the sigma xy here. Okay, so isa-substitute din natin yan. And nakuha na rin naman natin itong EB is equivalent to EF cosine theta. FB is equivalent to EF sine theta. Okay, so this time, ang gagamitin naman nating trigonomic identities would be sine 2 theta over 2 is equivalent to sine theta cosine theta. And cosine 2 theta is equivalent to cosine theta squared minus sine theta squared. So simplifying this, so following the same procedure, we can derive our equation of tau n is equivalent to sigma y minus sigma x over 2 times sine 2 theta minus sigma xy cosine 2 theta. So this will be our main equation, or our working equation rather, for sigma n, and this is our working equation for tau n. Okay? And we now proceed with our principal stresses. When we say principal stress, it is the maximum or the minimum stress. That's why they say principal. It is the maximum or the minimum. Okay? Take note that if two planes are perpendicular, therefore theta is equivalent to 90 degrees. Then tau n is equivalent to 0. So if babalikan natin tong equation 2.12 natin, equate natin yung tau n into 0. Tau n is equivalent to 0. Transfer this term to the other side of the equation, and transfer this to the other side of the equation, then cross multiply tau, cross multiply, kasi ang mangyayari niyan, sige, i-demonstrate natin. So pag na-transfer na to on the other side of the equation, mangyayari niyan, sine, copy natin, we have here, this is equivalent to this. Okay? Yan. Okay? Now, sine 2 theta over cosine 2 theta is equivalent to tangent. So, cross-multiply ulit ang mangyayari dyan. Okay? So, magkakaroon tayo ng cross-multiplication. Okay, so tau xy is equivalent to this equation here, copy paste, divided by tangent. Wait, gawin natin ganyan. Okay, so sine 2 theta here can be divided by cosine 2 theta. Okay, but sigma y minus sigma x over 2 can be cross multiplied again. Okay? And sine 2 theta divided by cosine 2 theta is tangent. Okay? So, ang nangyari dyan, we have tau xy here divided by this equation. Okay? Is equivalent to tangent to theta. Okay? Okay, so yan. Na-derive na natin yung ating equation 2.14. Now, from equation 2.14, we can derive the variables of a right triangle as shown. Okay? So, kung titignan mo, isn't it that this is a function of SOHCAHTOA? So, tangent is equivalent to opposite over adjacent. Okay? So, yan. Burahin natin tong part na to so we can see the diagram very well. Ayan. So, tangent 2 theta. So, this is the angle. So, you have 2 theta is equivalent to opposite. This is the opposite side. And this is the adjacent side. So, from there, we were able to draw our right triangle. So, 2 theta is equivalent to tau xy over sigma y minus sigma x over 2. Now, using Pythagorean theorem or the Pythagoras theorem, h, since this is the hypotenuse, h is equivalent to the square root of tau xy squared sigma y minus sigma x over 2 quantity squared. And that would be our equation 2.15. Now, consider equation of sigma n. So, balikan natin yung equation natin for sigma n. This is our working equation for sigma n. Now, substituting the value, okay? So, substituting the value or using the Pythagoras theorem that we were able to, the Pythagoras theorem, and we were able to derive functions. So, we have here 2 cosine theta. Diba? So, cosine 2 theta, yung cosine 2 theta natin dito, isa-substitute natin using our right triangle. Where? Wait. Ayun. Cosine 2 theta. And even the sine 2 theta. So, cosine 2 theta is theta, sigma y minus sigma x over 2 divided by h. Cosine function. So, cosine is equivalent to adjacent over hypotenuse. So, sigma y minus sigma x over 2 divided by h. So, this is a cosine function. Now, for the sine 2 theta is equivalent to tau xy over 2. And isubstitute natin yung sine theta. Okay? Later on naman din yon sa baba. We're only, tama. Pinalitan natin, yes. Okay, so substituting the sine 2 theta here and the cosine 2 theta here. And simplifying, sigma n is equivalent to sigma y plus sigma x over 2 plus quantity sigma y minus sigma x over 2 quantity squared plus tau xy squared over h. Now, substitute h from equation 2.15 in equation 2.17. So, ano ba yung value ng h natin? So, this is the value of h. So, if isa-substitute natin itong h na to dito sa equation natin on 2.17, then we can now derive our maximum major or maximum principal stress or sigma 1. Then for the minimum or minor principal stress, that is sigma 3. Okay, sinubstitute natin si h, simplify, then this will be our working equation for major principal stress. This will be our equation for major principal stress. Okay? Kasi kung i-simplify pa natin, i-enter pa natin lahat sila, isa-isahin natin, medyo mahihirapan tayo. Or hindi naman mahirapan, matatagalan tayo and we will be consuming so much time. But for your practice, I strongly suggest, try to do the derivation on your own, since I've already explained it naman how to do that. Okay, now take note, some notes using the derived equation. So angle theta is always measured from the global horizontal axis. So global horizontal axis, it would be this. It is from positive x-axis. Okay, so positive is if it is for normal stresses, positive it is compression. Kinocompress natin yung soil particle. This is our soil profile. Kinocompress siya, therefore it is positive. Okay, for normal stress. It is negative is if it is in tension or it is going away. It is going away from our soil profile or soil particles. Now for shear stresses, if it is positive, if it is outwards. Okay, so palabas. It is outwards or away from the vertex with the 90-degree angle. So this is our 90-degree angle, paalis siya sa 90-degree, positive. If it is towards our 90-degree, so this is our 90-degree, therefore it is a negative shear stress. So we keep that in mind para tama yung masosolve natin sa problem. Okay, so we have here sample 10.1 of page 340. A soil element is shown in figure 2.5. Determine the following. So this is figure 2.5 here. And we are to determine the maximum and the minimum principal stresses and the normal and shear stresses on the plane. So before we proceed, let us first identify our stresses here. So if this is our plane, so this will be our cutting plane, and we know that the force that is compressing towards our plane would be the sigma. So this is sigma x, 162 kilonewton per square meters, and this is sigma y. So the downward force here is also equivalent to the upward force here. So that is 128 kilopascals. Therefore, our shear stress is going away from our 90-degree angle here. Therefore, it is positive. So that is 32 kilopascals. Okay? Now, paano pag ganito yung itsura ng ating cutting plane? Okay? Or ganito yung itsura ng ating figure. Always remember na sabi kanina, the angle theta is always measured from the global horizontal axis. So it should always be with respect to the positive x-axis. So the theta that we are going to consider would be the angle from here. And since this is a rectangle, 55, then the angle here would be 35 degrees. Okay, so 35 degrees. That would be equivalent to 90 degrees. Okay? Yeah. So theta, this is theta. Theta here is 90 minus 55, that is 35 degrees. And 2 theta or 2 of 35 degrees is equivalent to 70 degrees. Now, what is our working equation for maximum stress or for sigma 1? Which we derived. It is sigma y plus sigma x over 2 plus the square root of sigma y minus sigma x over 2 quantity squared plus tau xy squared. So this is our working formula for maximum principal stress, and this is for minimum principal stress. So sigma 1 is equivalent to sigma y plus sigma x over 2 plus the quantity, the square root of quantity sigma y minus sigma x over 2 raised to the second power plus tau xy squared. And we know the values naman, so we can proceed with our solution. So sigma y is equivalent to 128 plus we have here sigma x, which is 162 divided by 2 plus the square root of open parenthesis, we have sigma y 128 minus 162 divided by 2 quantity raised to the second power plus tau xy. Take note, tau xy is positive 32. Okay, So we have 32 raised to the second power. Okay, so we can now proceed with calculating. So sabayan nyo ako, we have, bring out your calculator, 128 plus 162 divided by 2 plus the square root of 128 minus 162 divided by 2 raised to the second power plus 32 squared. And that is equivalent to 100. Wait. So that is 100. Yeah, tama. 181.235 kilo pascals. Actually, parehas lang naman si maximum shear stress and si minimum shear stress. It's just that for maximum, it is positive before the square root. For the minimum, it is negative. So we can simply copy this to lessen our solving time. So paste sigma 2. We have here sigma 2 and change this one into negative. Okay, so sigma, not sigma 2. It is sigma 3. Okay, therefore, sigma 3 is equivalent to, so palitan nyo lang yung plus sign ng negative sign sa calcu, and meron tayong sagot. That is equivalent to 108.765. And that's it. That is in kilo pascals. Okay, next would be the stress. So the stress along AB, sigma N. So babalikan natin yung diagram natin. This is AB and this is our stress. So aalamin natin yung normal stress and tangential stress. So going back, the formula that we were able to solve would be the first equation. So this is sigma tau n, the stress, the shear stress, and this is our normal stress. So we will be using these two equation. So ito lang naman ang kailangan yung i-memorize na apat na equation for stresses. So normal stress, shear stress, maximum, at saka minimum principal stresses. Okay, so yung apat lang na yun. So so using those equation, ayan. So, ito yung ating equation. Okay? So, substitute na natin yung ating mga values. So, sigma n is equivalent to, what is sigma y is 128 plus 162 over 2 plus, copy natin para hindi na tayo matagalan mag-type because they are just the same. But don't forget to subtract. And we have here cosine. Take note that we have here 2 theta. So 2 cosine, we have 2 times 35. Diba? Degree. 2 times 35 degree. Okay? But na-solve na natin yan kanina, which is 70 degree. Pwede na natin idiretso na 70 degree. Para wag na natin pahirapan sarili natin. Okay? So, 70 degree. Then, we have plus tau. Tau is 35. So, positive. That is plus 35. We have sine 70 degree. Okay? So, solving for the normal stress, we have 128 plus 162 over 2 plus 128 minus 162 over 2 cosine 70 plus 35 sine 70. Okay? That is 172. 172.075 kilopascals. Okay, so that is our normal stress. Now, for the shear stress. For the shear stress, kinopya na rin natin yung ating formula. So, ang gagawin na lang natin is substitute. So this is sigma y minus sigma x over 2. So kopyahin natin to. Tapos sine theta. So sine theta, cosine theta. So almost parehas. Then paste lang natin. Okay, adjust natin yung mga functions. So instead of cosine, it is sine. Then instead of plus, it is negative. Okay. Then sine, instead of sine, it is cosine. Cosine 70 degrees. Okay. And that is equivalent to 128 minus 162 over 2 sine 70 minus 35 cosine 70. Wait, is it 35? No, 32. May mali tayo dito. It's not 35. This one is 32. Wait, balikan natin. Okay, so 32 minus 32 cosine. And that is negative 26.919. That is in kilo pascals. Balikan lang natin ito because it should not be 35. That should be 32. So 128 that is 169. Let us now proceed with our next example. So we have here example 10.2 of page 346. A soil element is shown in figure 2.6. So determine the following. So we have a maximum and minimum principal stresses, and B, normal and shear stresses on plane AB. So this is our plane AB. So always remember that we are going to have our reference with respect to the positive x-axis. Okay? So 33 degrees here then is already our theta. So theta here is already 33 degrees. Therefore, 2 theta is equivalent to 66 degrees. Okay? Now, what is our sigma x? So this is our sigma x, 72 kilopascals. And our sigma y, so this is our sigma y, that is 121 kilopascals. Okay, then our tau xy, take note it is towards our 90 degrees. Therefore, our tau xy is negative 39 kilopascals. So negative 39 kilopascals. Okay, so we can now proceed with our solution. So maximum and minimum principal stresses. So this is our working equation. Since we know our values, we can now proceed with the solution. So we have here sigma y is equivalent to 121 plus the sigma x, which is equivalent to 72 divided by 2 plus the square root of quantity. So we have here 1 to 1 minus 72 divided by 2, then raised to the second power, plus what is tau xy. Tau xy is negative 39. So negative 39 raised to the second power. Therefore, that is equivalent to, bring out your calculator, join me, 121 plus 72 over 2 plus the square root of 121 minus 72 divided by 2 raised to the second power plus negative 39 squared. And that is equivalent to 142.557 kilopascals. Therefore, the principal or the maximum stress along plane AB is equivalent to 142.557 kilopascals. Now, for the minimum, parehas lang naman sila. Kopyahin na natin. Just be mindful of the sign. Okay? So, this one here would be negative instead of positive. So, palitan lang din natin nasa calculator. Then, that is already 50. Sigma 3, or the minimum stress, is equivalent to 50.443 kilopascals. Okay? So, we're already done with the maximum and the minimum stresses, principal stresses. We can now proceed with our normal stress. And for the normal stress, this is our working equation. So, substitute na. We have 121 minus 72 divided by 2 plus, no, it's not minus, it is plus. Okay, same pero different equation. So, minus na dito. Then, we have cosine times cosine of 2 theta. What is 2 theta? It is 66 degrees. So, we have here 66 degrees plus, we have tau. Tau here is negative 39. Okay? I repeat, it is negative 39. So, negative 39 sine 66 degrees. Okay, so sigma n is equivalent to, calculator ulit, we have 121 plus 72 divided by 2 plus 121 minus 72 over 2 times cosine 66 plus negative 39 times sine 66 degrees. And that is equivalent to 70.837 kilopascals. Okay? Now, for the shear stress, what is our working equation? This is our working equation for shear stress. Okay? Okay. So, substitute natin yung mga values. So, we have here, kopyahin na natin to, this term. So, we have 121 121 minus 72 over 2. This time, instead of cosine, we have sine. Minus, instead of plus, magiging negative 39. And instead of cosine, instead of sine, magiging cosine of 66. So, sigma y minus sigma x over 2. 1 to 1 minus 72 over 2. Sine 2 theta, sine 66 minus tau x cosine 2 theta minus negative 39 cosine 66. And shear stress is equivalent to, calculate natin, we have 121 minus 72 over 2 sine 66 minus negative 39 cosine 66. And that is equivalent to 38.245 kilopascals. Therefore, the shear stress along this plane is 38 kilopascals, and the normal stress pag ganyan, normal stress natin is 70.837 kilopascals. Okay?